Okay, let's talk about infrastructure as code, or IC for short. Basically, it's a way of managing your IT stuff using computer code instead of clicking through complicated interfaces. It's like building a house with instructions from a blueprint rather than laying each brick yourself. This approach lets us automate things, track changes so we can roll back if needed, and ensure everything is consistent across our different environments: development, testing, and production. You'll notice the benefits are huge. It saves time, reduces errors, and helps keep costs down. Okay, let's talk about why infrastructure as code is such a game changer. Basically, when you define your infrastructure like servers, databases, networks using code instead of manual processes, it unlocks some seriously powerful benefits. First off, things become much more repeatable and consistent. You're not relying on someone remembering a specific configuration. The code dictates exactly what gets built. And because you're managing it as code, it naturally lives in version control, so you can track changes, collaborate easily, and roll back to previous versions if something goes wrong. Automation is huge too. You can automate all sorts of tasks, reducing human error and saving a ton of time. Plus, by using an immutable approach, you minimize configuration drift, which significantly reduces risk. Finally, all these factors combine to make your team way more agile. You can deploy changes faster and experiment with new ideas without fear. Okay, let's dive into the tools we've used when it comes to infrastructure as code. I've worked with a few key platforms. Terraform is probably the one I've spent most time with. It really shines when you need to manage infrastructure across multiple cloud providers like AWS, Azure, and Google Cloud. Terraform has amazing community support, and state management is super important for keeping things consistent. Then there's CloudFormation, which is specifically designed for Amazon Web Services. It integrates seamlessly with AWS services, making it a solid choice if you're primarily working within the AWS environment. We also touched on Azure Resource Manager, which is native to Azure and provides powerful tools for managing your resources there. Let's talk about Terraform. Basically, infrastructure as code is a way to treat your service and other IT stuff like software. Instead of manually clicking through the Cloud Console, you write code that tells it exactly what you need. Terraform is one really popular tool for doing this, and it's designed in a really clever way called declarative. That means you tell it what * you want, not * how * to get there. It figures out the steps itself. It's like giving instructions to a robot. Instead of telling it every tiny movement, you just say make this table, and it knows how to build it. Terraform works across many different cloud providers, so if you're using AWS, Azure, or Google Cloud, it can handle everything for you, keeping track of your infrastructure's current state along the way. Okay, let's talk about AWS CloudFormation. It's really the building block for infrastructure as code within Amazon Web Services. Basically, you create these templates. Think of them like blueprints written in YAML or JSON that describe exactly what infrastructure you need: servers, storage, databases, everything. You upload this template to CloudFormation, and it does all the heavy lifting of actually creating and managing those resources for you. It's a fantastic way to ensure consistency and reliability because it's declarative, meaning you just say * what * you want, not * how * to get there. And because it's important, running the same template multiple times will always result in the same infrastructure. Plus, it integrates really well with version control systems like Git, making collaboration and rollback super easy. Okay, let's talk about the differences between Terraform and CloudFormation. Both are great tools for managing infrastructure as code, but they have some key distinctions. Terraform is really designed to be a multi-cloud solution. It can work with AWS, Azure, Google Cloud, and many others. It uses a declarative approach, meaning you tell it * what * you want your infrastructure to look like, not * how * to get there. Terraform also has robust state management, allowing you to track changes and ensure consistency across environments. CloudFormation, on the other hand, is steadily focused on AWS. While you can use it for declarative configurations now, it's historically been more of an imperative tool. And because it's native to AWS, CloudFormation leverages AWS managed state, simplifying some aspects of managing your infrastructure. Ultimately, the best choice depends on your specific needs and whether you're primarily working within a single cloud or across multiple providers. Let's talk about Terraform providers. Essentially, they're the bridge between Terraform and your cloud provider like AWS, Azure, or Google Cloud. They act as translators, allowing Terraform to understand how to create and manage resources on those platforms. Think of it this way: Terraform speaks its own language, HCL, but the cloud needs to hear a different language. The provider takes care of converting that communication. For example, the AWS provider lets you work with all sorts of things in AWS, from virtual machines to databases. And Terraform automatically finds and uses these providers for you, making it super easy to get started. Okay, let's talk about Terraform modules. They're essentially reusable components like building blocks for your infrastructure code. Imagine you need to create a virtual private cloud in several different environments: development, staging, and production. Without modules, you have to copy and paste the same configuration over and over again. Modules let you define this core VPC setup once and then easily reuse it everywhere. They also help keep things organized, making updates simpler, and promoting consistency across your team. Okay, let's talk about how Terraform remembers everything it does with your infrastructure. That's managed by something called state. Think of it as a record book for all the resources Terraform has created and modified. It keeps track of their names, configurations, and current status. There are two main ways to store this, locally on your computer or remotely in a place like S3 or Azure Storage. That's the preferred method because it makes collaboration much easier and prevents problems if someone messes up their local copy. Okay, let's dive into the world of TF state files in Terraform. These are basically Terraform's memory banks that store all the information about everything Terraform is managing for you. Without a TF state file, Terraform wouldn't be able to keep track of changes and consistently recreate your infrastructure, which could lead to some serious headaches. It's like having a detailed logbook of every resource Terraform has touched. Think of it as a record of what exists, how it's configured, and any modifications that have been made. Terraform uses this file to compare your desired state, the one you've defined in your configuration files, with the actual state of your infrastructure. Then, it makes only the changes needed to get everything aligned. Just remember, never manually edit a TF state file, let Terraform handle it. Okay, let's talk about Terraform backends. Basically, they are a super important place where Terraform keeps track of all the infrastructure you're building, everything from servers to databases. Without the backend, Terraform would just lose that information every time you close your laptop. It's like having a permanent record and makes it possible for multiple people to work on the same project without stepping on each other's toes. There are different types of backends, with local storage being fine for testing but not really suitable for real-world use. The best approach is to store it in a remote service like S3, which gives you extra security and makes collaboration much smoother. Okay, let's talk about keeping your infrastructure secure, specifically around secrets. It's absolutely crucial not to just throw your passwords or API keys directly into your Terraform code. That's a huge security risk. The good news is there are some really solid ways to handle this properly. First, if you're using Terraform Cloud or Enterprise, they have built-in secret management that's super convenient and secure. Then, HashiCorp Vault is another fantastic option. It allows you to securely store all your secrets in one place and then dynamically inject them into your infrastructure as needed. And finally, don't forget about utilizing the native secret management services offered by your cloud provider like AWS Secrets Manager or Azure Key Vault. These are designed specifically for this purpose. Let's talk about Terraform Cloud. It's essentially a central control panel for all your Terraform projects. Instead of managing everything on individual computers, you can run it all from this one place. This solves the tricky issue of snowflake states, ensuring everyone is working with the same up-to-date infrastructure information. It makes remote execution super easy, no more complicated setups. Plus, workspaces let teams work independently without stepping on each other's toes, and secure secret management keeps your sensitive data safe. It's a huge step towards streamlined and collaborative infrastructure management. Okay, let's talk about the difference between Terraform's plan and apply commands. Plan is like a practice run. It shows you exactly what changes Terraform *would make to your infrastructure if you were to actually apply them. It's a great way to catch potential issues or conflicts before they cause problems. Then, when you're happy with the proposed changes, you use apply. That's where Terraform actually goes out and builds, updates, or deletes resources in your cloud environment. So always run plan first to make sure you understand what apply is going to do. Okay, let's talk about workspaces in Terraform. Basically, they're like separate folders for your infrastructure projects. You can use a single Terraform configuration to define all the resources needed for different environments, say, development, staging, and production. Each environment gets its own workspace, which keeps everything neatly isolated. This means you don't accidentally deploy changes from one environment into another, preventing those frustrating unexpected updates. Okay, let's talk about managing infrastructure across different environments like development, staging, and production using Terraform. The key here isn't just running the same code everywhere, it's about making sure everything is isolated and consistent. We do this primarily by utilizing variables. Think of them as placeholders that you can customize for each environment. Then, we use modules to create reusable components that are also adaptable. Finally, workspaces give us a really clean way to manage multiple Terraform states without stepping on each other's toes. And remember, automation is absolutely essential. Using CI/CD pipelines ensures your environments stay in sync with your code. Okay, let's talk about keeping track of changes to your infrastructure. Terraform has fantastic built-in versioning features. At the heart of it is the Terraform TF state file. This is Terraform's memory of all the resources you've created and how they're configured. It's super important to manage this carefully. For teams, storing the state remotely in something like S3 or Azure Storage account is really the way to go. It makes sure everyone's working with the same information. You can also version your entire Terraform code using Git. That's a good habit for tracking all changes and being able to roll back if needed. Terraform itself tracks changes to your configuration files, so you automatically get versions of each update. Let's talk about CloudFormation templates. Basically, they're like recipe books for your AWS infrastructure. Instead of manually setting up each resource through the console, you write a template which is just a file describing everything you want in your cloud environment. It's all based on what you want it to look like, not how AWS should build it. These templates are written in either YAML or JSON, and they're incredibly reusable, so you can copy them for different projects and deployments. Okay, let's talk about how CloudFormation handles infrastructure definitions. It primarily uses JSON-less JavaScript object notation. JSON is super structured and really well supported by a lot of tools. But it can be pretty verbose, meaning you need to write a lot more characters to describe your infrastructure. On the other hand, YAML, which stands for YAML Ain't Markup Language, offers a much more human-friendly way to do things. It uses indentation instead of brackets and braces to define its structure, making it easier to read and understand at a glance. And because it's less verbose than JSON, your CloudFormation files will be smaller. There are trade-offs. JSON is often easier to debug with linters, but YAML can make simpler configurations much clearer to work with. Okay, let's talk about CloudFormation stacks. They're really important for managing our AWS infrastructure with code. Essentially, a stack is like a blueprint, a collection of related resources we want to create and manage together. It can be as simple as one EC2 instance or as complex as an entire web application architecture. The key thing to understand is that stacks are built around resource definitions, things like servers, storage, databases, you name it. We can customize these stacks using parameters, which are basically variables that let us tailor the infrastructure to our specific needs. And when the stack is created, it generates outputs, useful values we can use in other parts of our system. Think of them as a controlled way to define and deploy entire environments one step at a time. Okay, let's talk about something really useful in CloudFormation: nested stacks. Imagine you're building with Lego. You start with a base layer, then you add more and more layers on top of that, each adding its own little structures. Nested stacks are kind of like that. They're essentially stacks inside of stacks. A parent stack is the big picture. It decides when to create its children, these nested stacks. And those nested stacks can even have their own resources and dependencies. Using nested stacks helps you build really modular, reusable infrastructure, making things much easier to manage as your projects grow. Let's talk about updating your CloudFormation stacks. There are several ways you can do this. You can manually trigger an update through the console, or use the AWS command line interface or SDK for automated updates. A really powerful option is using lifecycle hooks in your templates to schedule updates automatically. During an update, CloudFormation validates your changes, creates a detailed change set that you should always review carefully, and then applies those modifications. If anything goes wrong during the process, it will attempt to roll back to the previous state. It's really important to take time to look at those change sets before applying any update. That's your safety net. Okay, let's talk about change sets in CloudFormation. Essentially, they're a really powerful way to tweak your infrastructure without having to rebuild everything from the ground up. Imagine you need to update a single parameter value on one of your resources with a regular stack deployment. You'd have to recreate the whole thing. A change set lets you pinpoint exactly what needs changing, validate that it's safe, and then apply those updates efficiently. It's like having an edit button for your infrastructure. You define the changes in a file, CloudFormation checks them out, and then applies only those modifications to your existing stack. Okay, let's talk about drift detection in CloudFormation. Basically, it's all about ensuring that what you think your infrastructure looks like matches what's actually running. CloudFormation helps with this by creating change sets. Whenever you update a template, they really detail exactly what will be changed. Beyond those, there's stack drift detection, which constantly compares the current state to what you defined in your template. To help you catch these issues early, we can set drift thresholds. Think of them as alerts for significant differences. It's super important to review these change sets regularly and to combine that with automated testing and version control. That way, you're proactively managing potential problems. Let's talk about how CloudFormation makes sure everything gets built in the right order. Think of it like building a Lego set. You can't attach the roof until you have the walls and base. CloudFormation automatically figures out which resources depend on each other, creating a dependency graph. This lets it build your infrastructure step by step, ensuring that things like network security groups are created before instances try to connect to them. It's all about building in a logical sequence for reliable deployments. Okay, let's talk about intrinsic functions in CloudFormation. Think of these as built-in tools like little helpers that you use inside your templates to dynamically create values or manipulate resources. They're super useful for generating things on the fly based on parameters you set, making your infrastructure definitions much more flexible and readable. We've got a few common examples here, like fn, sub, which lets you substitute placeholders into strings, fn, join that combines elements into one string, and even fn, import to bring in resources from other places. Basically, they help you avoid repeating yourself and build really powerful infrastructure as code. Let's talk about making your CloudFormation deployments more manageable. When you're spinning up infrastructure across different environments, or even just for similar projects, it can get really messy if you're copying and pasting code everywhere. The key to solving this is reusability. CloudFormation offers great tools for this, primarily through modules. These are like mini templates that group related resources together. You also want to use parameters to customize those modules so they work across different environments. Outputs let you share specific values from one module with others, and nested modules allow you to build even more complex deployments in a structured way. Remember to document your modules well and test them thoroughly. It's all about keeping things consistent and reducing errors. Okay, so when you run Terraform plan, it's not just instantly making changes to your cloud environment. Instead, Terraform does a really smart thing. It creates an execution plan. Think of this as a rehearsal. It outlines exactly what actions it would take if you then ran Terraform apply. It lists all the resources that need creating, modifying, or even removing. The plan uses your current state to compare against what you want and shows you the step-by-step roadmap for those changes. Okay, so Terraform's apply command is your go-to for building out infrastructure, but sometimes things don't go smoothly. If a midway failure occurs during an apply, don't panic. Terraform has built-in safety features. It automatically tries to undo the changes that caused the problem, essentially hitting reverse on your deployment. Even after it rolls back, you need to pay attention to the output because it'll tell you exactly what went wrong and which resource was causing issues. Think of it as a helpful debugging tool. Terraform provides details like the failing resource, the specific error message, and a list of the resources that were successfully applied before the problem arose. Okay, let's talk about getting your existing infrastructure into Terraform. It's totally normal to feel like a big task, but it's really worth the effort. First, you need to understand exactly what you're working with. Take stock of all your servers, networks, and databases. Tools can help you map everything out. Then, if you're using CloudFormation, export those templates as JSON files. It's a little bit like creating a blueprint for your existing setup. Next, you'll need to connect the dots between what you have now and what Terraform needs. This often involves some tweaking, changing things like instance types or security rules. Don't worry, it's perfectly fine if things aren't identical at first. Run Terraform in it to get everything set up, and then use Terraform apply to start building your new infrastructure. Remember to take it step by step and validate those configurations before you go live. And don't be afraid to ask for help. There are tools out there designed to make this process easier. Okay, let's talk about how we describe infrastructure changes. When you're provisioning infrastructure, there are two main ways to approach it: imperative and declarative. Imperative is like giving a detailed recipe to tell the system exactly what each step should be, one by one. It's more verbose and can easily lead to errors if you miss something. On the other hand, declarative is much simpler. You just describe the desired state of your infrastructure. Things like I want to VM with these specific configurations. Terraform and CloudFormation then figure out the steps needed to get there automatically. Declarative is generally preferred because it's more reliable and easier to manage in the long run. Let's talk about Terraform data sources. They are essentially a way to get information from outside of your infrastructure code, things like database credentials, API endpoints, or even the current state of a service. Instead of hard-coding values that might become outdated, you use a data source to dynamically fetch those values during planning and apply phases. It's really useful when you need values that change frequently or want to create reusable code blocks that can adapt based on external information. There are all sorts of different types, like accessing DynamoDB tables, S3 buckets, or even checking the health of your servers. As you can see in this simple example, a data source lets you query AWS for the latest Amazon-owned AMI. Super handy. Okay, let's talk about outputs in Terraform. They are surprisingly powerful. Essentially, outputs are like little snapshots of information generated during your infrastructure deployments. Think of them as a way to expose dynamic data, such as IP addresses or URL. They are super useful for integrating your Terraform code with other tools and services, letting you easily configure things based on what Terraform has just created. For example, you might want to get the public IP address of an instance so you can point a DNS record to it, or share the ARN of a database with another application. The code snippet shows how easy it is to define an output and retrieve the value. It's a really convenient way to make your infrastructure more flexible. Okay, so let's talk about provisions in Terraform. Essentially, they're like the finishing touches after you built your infrastructure with Terraform. They run after your resources, servers, databases, whatever are actually created. Instead of just deploying them, provisioners do things like install software on those servers, configure services to be running, and even set up users and security settings. It's a really convenient way to make sure everything is exactly how you want it, and Terraform manages the execution reliably across all your different environments. Okay, let's talk about when you might want to step away from Terraform provisioners. Provisioners like local exec or remote exec are super powerful for doing things that aren't directly covered by Terraform's declarative language. But honestly, they can quickly make your infrastructure setup a lot more complicated and harder to manage. Think of it this way: each provisioner is essentially a little script running during deployment. That adds complexity because you have to maintain all those scripts, debug them, and ensure everything stays consistent. You also need to be really careful about state management. These scripts can sometimes cause your Terraform state to drift out of sync. The good news is there are usually better ways. Modules let you reuse logic across different environments, data sources, and transforms allow you to manipulate data within your code, and if absolutely necessary, external scripts should be used with extreme caution. Okay, so we've got our infrastructure as code all set up fantastic. But it's super important to make sure that code actually does what we want it to do. Think of testing IC like writing tests for any other piece of software. We don't just blindly deploy, we check things out first. First, let's look at why testing is so vital. It helps prevent those nasty deployment failures, keeps our environments consistent, and drastically reduces the risk of downtime. There are a bunch of ways to approach this, starting with simple static analysis tools like Terraform Validate or CloudFormation Validation that check your code for errors before you even touch a server. Then we've got unit tests to test individual parts, integration tests to see how they all work together, and end-to-end tests to really simulate real user workflows. Finally, validation techniques help us ensure our templates match the expected schema and enforce rules. It's about building confidence that your infrastructure is behaving as anticipated. Okay, so when we're using infrastructure as code, whether it's Terraform or CloudFormation, security needs to be a top priority. First off, never ever put secrets like passwords or API keys directly into your code. Instead, use a dedicated secrets management service. Next, think about least privilege access. Give your components and users only the permissions they absolutely need. Then, embrace immutable infrastructure. Don't modify existing servers or build them instead. Regular code reviews, coupled with static analysis tools to catch potential vulnerabilities early, are crucial. And finally, always use version control for your ISC files. It's a continuous effort, so keep an eye on security best practices and update them as needed. Okay, so let's talk about making sure our infrastructure code is solid before we actually deploy it. Essentially, linting and static analysis are like giving your Terraform or CloudFormation templates a thorough checkup. Why do we need to do this? Well, catching errors early before they cause problems in production is key. These tools help us enforce code quality, make sure everything's consistent, and spot potential security risks before they become actual vulnerabilities. We've got built-in linters for both Terraform and CloudFormation, and then there are more advanced static analysis tools like TSEC and Checkov that can dig deeper into things like security and compliance. Let's quickly look at some of the common checks. These tools perform things like catching syntax errors, finding duplicate resource names to avoid conflicts, spotting potential security weaknesses, and ensuring your code meets your organization's policies. Okay, so let's talk about a really important issue when we're using infrastructure as code: configuration drift. Basically, this happens when what's actually running in your cloud environment doesn't match exactly what you defined in your code. There are several reasons for this. Sometimes people make changes directly to the infrastructure without using our IC tools, or updates can accidentally introduce new configurations. We need to be aware of these potential causes and, more importantly, how to manage them. Fortunately, Terraform and CloudFormation have built-in capabilities to help us detect drift. Terraform tracks your infrastructure's state so we can compare that state to our code and spot any differences. CloudFormation uses tagging and versioning, which allows us to roll back if something goes wrong. And both tools offer different tools to show you exactly what's changed. But detection is just the first step. We need strategies to actually fix it. That includes things like creating automated remediation runbooks, using GitOps practices, treating our ISC code like any other application source code, and regularly auditing our infrastructure to ensure everything aligns with our defined state. Okay, let's talk about state locking in Terraform. Basically, Terraform keeps track of all the resources it's managing. Think of it like a detailed logbook of everything you've built. This logbook or state file is super important because it allows Terraform to reliably recreate your infrastructure if needed. But what happens when multiple people are trying to update things at the same time? That's where state locking comes in. It's like putting a lock on that logbook. Only one person can edit it at a time, preventing conflicts and ensuring everyone gets the same consistent view of your systems. Terraform uses an object storage bucket like S3 for a state file and leverages the bucket's built-in concurrency control to do this locking. It might add a little bit of wait time during deployments, but the benefits in terms of reliability and preventing errors are absolutely worth it. Okay, let's talk about state. It's a really important concept when you're using Terraform. Basically, Terraform keeps track of all the resources it manages in something called state. Think of it like a record book for your infrastructure. Now, storing that record book locally can be tricky. If multiple people are working on the same stuff, they could accidentally overwrite each other's changes. Plus, state files aren't really designed to live inside version control systems. That's where remote state comes in. It lets you store that record book in a safe, reliable place like an object storage service like AWS S3 or Azure Blob Storage. It allows for seamless collaboration and helps keep everything consistent. Let's look at a quick example of how to set this up with AWS S3. Okay, let's talk about Terraform State. Basically, it's like a memory for your infrastructure code. It keeps track of all the resources you've provisioned. There are two main types: local and remote. Local state is just a file stored on your computer, handy for individual work but tricky to share and prone to conflicts if multiple people are working at once. Remote state, however, lives in a central place like cloud storage, ensuring everyone has the same consistent view of everything and making collaboration much smoother. Super helpful when teams are involved. Okay, let's discuss how to handle things when our infrastructure changes don't go quite as planned. We need rollbacks. Terraform makes this really easy with the Terraform apply destroy command. It essentially wipes out everything and then reverses back to your last good state. CloudFormation manages rollbacks through stack update history. You can simply rewind to a previous version of the stack. Remember, both tools depend on keeping track of your infrastructure's state, so make sure that's properly managed. Okay, let's talk about the Terraform registry. It's essentially a massive online library for your Terraform code. Think of it like GitHub, but specifically for infrastructure things like virtual machines, networks, and databases. The registry hosts reusable modules that you can download and incorporate into your own configurations, saving you tons of time and effort. It also contains providers. These are the pieces of software that actually talk to cloud services like AWS or Azure. And finally, it has components, which are smaller building blocks you can use together. Let's talk about parameter files in CloudFormation. Think of them as a way to make your templates more adaptable and reusable. Instead of hard-coding values directly into the template, you define these settings in a separate file, often called parameters.json. This is great because you can use the same template multiple times with different configurations without having to rewrite it each time. You can set default values so that stacks will still work if you don't provide all the parameters, and you can even create nested parameter structures for really complex setups. The key types are strings, numbers, booleans, lists, and maps, giving you a lot of flexibility in how you define your settings. Okay, let's talk about something really cool in CloudFormation, custom resources. Basically, CloudFormation has some built-in resources like EC2 instances or S3 buckets, but sometimes you need to do things that aren't covered by those. That's where custom resources come in. They're like your own special building blocks. You can use them to add custom logic, integrate with other services, and really tailor CloudFormation to your specific needs. They work through a custom lambda function called the provider, which manages the resource's lifecycle, creating it, updating it, deleting it, and you define everything in a template just like you would with any other standard CloudFormation resource. Okay, so the key is automating how we deploy our infrastructure. It starts with your code changes triggering the pipeline. First, we do some quick checks like making sure our Terraform or CloudFormation files are valid and secure using tools that spot potential problems early on. Then, if everything looks good, we generate a plan to show us exactly what will be changed. We review this plan to make sure it's right before actually making those changes. And finally, we don't just hope it worked. We run automated tests afterward to confirm everything is up and running correctly, and if something goes wrong, we quickly roll back. Okay, let's talk about some of the real hurdles teams face when they're trying to roll out infrastructure as code. It's not just about installing Terraform, it's about getting everyone on board. You'll often find that different teams have completely separate ways of doing things and sometimes competing priorities that can lead to confusion and duplication. Then, you've got the skills piece. IC requires a different mindset than traditional development. Many developers aren't familiar with coding infrastructure, so training is essential. And let's be honest, choosing the right tools and making sure they all work together can feel really complicated. Finally, managing the state of your infrastructure, that's how you keep track of changes, is crucial in large teams, and preventing inconsistencies drift is a constant battle. Okay, let's dive into documentation for your infrastructure as code projects, particularly when using Terraform or CloudFormation. It can seem daunting at first, but a good strategy makes all the difference. I start with project level docs, basically a readme that explains what this whole thing is about, how to run it, and any important notes. Then, I move down to individual modules or resources, adding comments within the code itself to explain their purpose and settings. It's also really important to document your state management way of storing it and any security measures in place. Version control is a must-have too, linking to specific commits helps with traceability. And finally, don't forget about operational runbook step-by-step guides for common tasks like deploying new environments or scaling resources. The key here is automation wherever possible, keeping things concise, and ensuring the documentation stays up to date alongside your code. Thank you for watching.